Hi, everyone. So I like thinking about busting out walls and installing Windows when I think about DevOps and any existing software security lifecycle. You've probably heard the saying that you can't build a house without a solid foundation, which is something that I've heard many times when people talk about architectures and development. And if you look at DevOps and your build and deployment pipelines, your tool sets, your automation, and your culture, they're all part of your building, foundation and all. And choosing and applying your software security program to any existing SDLC should just be like busting out a few holes in your walls, a couple holes in your roof, and installing some skylights and some windows. So in an organization as large as Aetna, the seeds of DevOps are happening just about everywhere. We have over 3,500 developers located across the globe, and they develop more than 1,500 applications. You can imagine that with an organization so large and so widespread across the world, it's quite difficult to have a consistent implementation of any methodology across disparate teams. And even so, we continue to define processes and procedures around our software security programs, and we make these available to our core groups and our subsidiaries and affiliates. Traditionally, Aetna has been a waterfall organization. Sorry, I'm going to cringe a little bit. But after acquiring multiple companies and expanding its subsidiary network, new processes and methodologies are in place and agile, and they've been added to the landscape as they start to influence the way Aetna thinks about developing software. Now, we're based in Denver, Colorado. I'm fortunate enough to be responsible for the security guidance and some of the programs for a subsidiary we have there called iTriage that Aetna purchased back in 2011. And they'd already created and matured a DevOps culture centered on communication, collaboration, tools, and automation. Founded in 2008, they've been using containers, DevOps, microservice architectures long before they were acquired by Aetna. And they weren't the only ones that were doing DevOps in the greater Aetna organization, but as we grew our security program there, we started to feed our knowledge and our learning back into the greater enterprise inside of Aetna. So today I'm going to talk to you about the Aetna journey from waterfall to DevOps, and specifically about some of the improvements that we did at iTriage to introduce security controls into our processes. It's been a long and continuous journey that has taught us a lot of lessons and provided value and improved our security posture and reduced our overall risk exposure. I'll discuss some of the needs that we identified as we implemented security controls and policies around our container deployments and how we identify risk in our AWS infrastructure. Along this journey, we used measurements and KPIs to provide development teams and business stakeholders valuable security-related analytics about how their teams are operating. Information tells a story to the greater organization about how processes are operating and how successful, or for that matter, unsuccessful, everything is running. You see, if you can take concrete data and information and show how your security programs are operating in your automated software development lifecycle, it makes it very easy for traditional teams using other development methodology to understand and see value in what you're doing. It also shows these other teams in your organization that there's alternative ways of doing things. And basically, it's an alternative way of doing things based on collaboration, automation, and information. And when you add security to this mix, people start feeling more comfortable about investigating these new ways of doing things. And you'll see questions starting to be asked, and this is where innovation and evolution of your cycles and your software security lifecycle, that begins at that time. So we're going to begin by looking at Aetna's traditional approach to addressing software security and in our development lifecycle. And with an audience of DevOps practitioners, I'm pretty sure that everyone's cringing right now because this is a waterfall methodology. And there was a time and place for waterfall, but as projects move into modern infrastructure and rapid development, basically things are starting to change. And the way of producing software is becoming eclipsed by Agile and DevOps. And at Aetna, it's absolutely no different. In our traditional software security program, you'll see a big bloat of preventative tasks that happen at the beginning of our cycle before an application even gets into production. And during the requirements phase here, we develop security requirements for our products. In design phase, we do threat modeling and secure application design. And this basically was over and over again. So as we look at our biggest inefficiencies in this approach, it was in our development phase. So our static code analysis tools, for example, were done using IDE plugins and at the developer machine level. And although effective, there was little visibility into what was happening here on developer machines. So one of the other drawbacks of using IDE plugins was that they're only available for specific tools. And across an enterprise that uses multiple tools, multiple deployment destinations, and multiple on-premises and in the cloud infrastructures, it was really difficult to have these kind of IDE plugins that really limited developer tool selection. And sometimes it forced developers to use less effective tool sets. In addition, using these plugins on large projects inevitably led to machine slowdowns and IDE slowdowns in many instances. Of note in this diagram, though, is the cost to fix. And in the waterfall process, the cost to fix security process, or vulnerabilities, rose as features went from development into production. And everyone here has probably felt that pain of finding a defect in production and then running it right back through the cycle again and waiting for another production release. So let's get off this slide before. So at Aetna, we see integrating security into our DevOps process as an unprecedented opportunity. It allows us to build product features faster. Automation increases our efficiency and eliminates human error, and combined with continual optimizations and feedback, it facilitates the adoption of more progressive infrastructure and management practice and provides us with the opportunity to release better, more secure, and cleaner software. When we defined our DevOps practices at Aetna, we pulled the best practices and experience from not only internally, but more from our affiliates. And we ensured that our core concepts of our software security program that we've had available for a long time inside of Aetna were still intact. So this looks probably a little bit better. Imagine this picture is being iterative, though. So, where processes go from requirements design to development to CI to interval-triggered assessments to production, and then it repeats itself. So you'll see that we still have a bunch of preventative tasks that happen at the beginning of the life cycle, but they occur iteratively in an automated fashion. And we also introduced the concept of security mavens into our process. So, oops, sorry. Let me get back here. So we bring security mavens into our, hold on here. I'm lost. There we go. Thank you. So we introduced the concept of security mavens into our process, and these are specifically trained developers or operations engineers who are embedded into each agile team. And the mavens run security points, so they go through a rigorous testing and training curriculum to train them on vulnerabilities of security and that happen, that can apply to their code bases. And what they do is we embed security here at the cultural level of DevOps for our organization. So of note here is the SDLC itself is owned by the development team. In Global Security, which is an organization inside of Aetna that manages security programs for affiliates and internal resources, we simply embed the security controls at the appropriate places in the process to empower developers. We try to stay out of their way. Developers learn in that way how to secure their code against known vulnerabilities and in turn become better coders and security architects. We also add continuous monitoring, analytics, and KPI gathering to the process. By extracting information about the CI/CD program, we can ensure that security controls we inject into the process don't obstruct or bottleneck the flow of producing high-quality and secure software. The information also allows us to iterate on the integration of our security program. We can consistently improve the program, change what isn't working, and bolster up what is. And you notice here that the cost to fix arrow is absent. We believe that with a well-tuned CI/CD process and creating and deploying a patch to production to address a security vulnerability shouldn't be any different than just deploying and fixing or pushing a feature into production as well. Defect remediation and feature development move through the process in a similar automated fashion with minimal human interaction pushing into our production environments. So we're going to take a look at some of the specific processes here around software code analysis, container vulnerability scanning, and how we do some of our AWS infrastructure security. So static code analysis was one of the first security controls we implemented in our software development lifecycle. Our main goal here was to improve code security, reduce defect density, and to provide continuous security feedback to our developers in an unobtrusive way. So in my past life as a developer, there's nothing I hated more than being blocked because of a security vulnerability, and I couldn't check my code in because my master branch was being held up, or to the master branch because my code was being held up by a security vulnerability test. So to address these goals, we chose to integrate our static code analysis tools in our source control management and build platforms. Using a Git flow branching and merging strategy and our source control software, we implemented a pull request process where developers would combine one or many of their changes and issue a request for those changes to be integrated in the master branch of code. For these pull requests to be approved, we required a full successful build, successful static code analysis, and two human approvals to be done. Then the code was allowed to be merged. So we looked at human approvals for ensuring adherence to our coding standards and as an opportunity to cross-train developers and learn. And having a human element inside of a DevOps process sort of goes against the grain of really what we want to accomplish. We believe, though, that once developers learn more about security and more about just implementing secure coding practices into their day-to-day jobs, that we could eventually remove some of those manual intervention points and maybe automate them in the future. So in order to increase our overall security posture and code quality, we introduced thresholds to do what we did, or to do what we call stop the bleeding. We would perform an initial scan of our code and then pass thresholds, or apply thresholds to our check-in process. So basically, when we checked in, if the number of high vulnerabilities detected were equal or less than the vulnerabilities detected in the previous build, we'd allow that check-in to go through. And then we created a script that would drop these thresholds if the current number of high vulnerabilities was less than the last build. And then you can incent your developers at that point. So in doing this, we prohibited developers from checking in new vulnerabilities into the code base. And we began a process and a journey towards doing defect, or what we call defect zero, or defect density zero. And this over time improved our defect density significantly. So we calculate defect density by determining how many vulnerabilities exist for 10,000 lines of code. And we set an acceptable level at 1.0 or 1.0. And we worked really hard across our organization to get to this level. And to do all of this, we needed to utilize an SCA platform that had APIs to pull data from. And we love APIs at Aetna. We love integrating with whatever we can. So any product or service that has an API, usually we lean towards. So once we had static code analysis covered, this enabled us to integrate with open source software management platforms in a similar kind of fashion. And these tool sets allowed us to detect undesirable software licenses, outdated open source components, and any reported bugs or security risks. With our approach to adding SCA into our process, we succeeded in pushing the static code analysis into the CI/CD level in space, but we noticed some potential issues here. We identified that when we integrated into the pull request process and ran static code analysis against large repositories, this could often slow down the delivery of software. And like this is 2 minutes to scan, or 5 minutes, but any delay of that long is somewhat undesirable for developers. So for larger solutions, we removed this mandate that we do static code analysis inside the pull request process, and we do nightly scans instead. And when these scans fail, we send automated emails out to the developers and create automated tickets in our ticketing system. Let's say they have to fix this issue within 24 hours. So containerization is a relatively new concept to Aetna, but they've been used for many years at some of our affiliates and our subsidiaries. As I mentioned previously, iTriage had been using containers for years. In fact, they developed their own container deployment system long before any commercial product was even available. And they called this platform Utopia, and it wasn't unlike Heroku or Docker Cloud in some cases, although it provided a much more customized functionality for our business. Now we're moving towards more commercial products as we've retired some of our older, antiquated, home-rolled solutions. So securing containers was something new to all of us, although we had long been utilizing them at our affiliates and running them through rigorous QA processes. We needed to find an automated way to check them for vulnerabilities and apply security controls to them. So in 2015, we were introduced to the Center for Internet Security's Docker benchmark, and we immediately began looking at ways to automate some of these audit checks into our SDLC. It turned out that this was just the tip of the iceberg. in really securing our containers. The CIS benchmarks, they helped us hardening the contents of our containers and what went in them and how they operated, but it didn't scan the contents of the images for security-related vulnerabilities or really show us how to apply or allow us to apply policy and governance to our container deployments. So we wanted to find a solution that provided security policy enforcement. For example, we wanted to enforce that any running container would only have one port open and that all file systems were marked read-only so our containers would be immutable. And most important of all, that our containers were not running as a root account. And this was something that we detected everywhere until we patched all these holes. But we were faced with the issue that our developers could just pull any image down off the internet and just use that as their base image for deployments. And we needed a way to apply policy and governance to that to ensure that developers just couldn't reach out to Docker Hub and pull whatever they wanted to and start developing more software. So fortunately, we found a vendor that provided commercial software which fulfilled all these needs. So for most of 2016, we vigorously tested this platform in both our AWS infrastructure and our on-premises infrastructure in our data centers. And over the next few months, we're rolling this out to our entire organization for both on-prem and off-prem software deployments, and we're going to be heavily relying on this for our container security and our vulnerability analysis. So the final component of our modernized software security program I'd like to talk about today is how we secure or how we determine risk in our AWS infrastructure. Back in February of last year, the Center for Internet Security released their AWS Foundations benchmarks, and it gave us prescriptive guidance for securing a subset of our Amazon Web Services. It was a welcome document for the team at iTriage and more so for the global security organization at Aetna. So we had done our best in hardening the infrastructure using best practices and policies that we defined over the years for traditional on-prem infrastructure. But there's still a general feeling, or there was still a general feeling in Aetna that cloud infrastructure just wasn't as secure as on-prem solutions. So this document gave us a great conversation starter with the more traditional development teams about how we could harden and secure our cloud environments. One of the things we quickly realized was how daunting of a task it was to go through the document and check every element manually in our AWS accounts. Similar to what we did with the container audit scripts, we attempted scripting these checks using the AWS CLI and scheduling the scripts to run at a regular interval. Over the next few months, we also encountered other scripting efforts that were made open source, and we tried to leverage those as much as possible to help scan and secure our AWS environments. So shortly afterwards, when our CSO introduced us to a vendor that was developing a platform which performed all these checks that were contained in the AWS Foundations benchmarks, and we'd immediately started a proof of concept to evaluate this software, and we quickly found that not only did it give us a great dashboard showing the risk posture in AWS, but it provided the ability for us to customize our own security tests using languages we already knew in-house, and to pull all the data we loved or we needed out of the system via API, and again, we love APIs. So the platform allowed us to stop focusing on developing software to check our infrastructure and to really start customizing so we can enforce additional security policies we had defined in our more traditional infrastructures. We discovered that as we reevaluated these traditional security policies, we had the opportunity to freshen them up and modernize them. So threats constantly evolve and change over time. And what was acceptable years ago for on-premises physical infrastructure didn't necessarily map directly to what we were doing in the cloud and our cloud deployments. Nor did it map to what the threat landscape is today. So we've learned that we could increase our security in the cloud by implementing stricter controls and then checking for compliance using automated scripts in our scanning platform. Today, this platform monitors all of our AWS accounts enterprise-wide. It allows us to quickly identify any risk and remediate them in our cloud infrastructure. And for Aetna, the Foundations benchmark in this platform allows us to have complete transparency across regions and availability zones for both our AWS accounts as well as our subsidiaries and our affiliates accounts. So automation of the CI/CD process and the tools and the cultural adoption is just the tip of our DevOps iceberg. These tools and techniques provide us with important information and a ton of it. The automation we've developed and our continuous integration and deployment pipeline would be great on their own, but they're even better when we extract KPIs from the process. Key performance indicators allow us to measure the health and effectiveness of our software security program's operation inside the SDLC, from the time a piece of code is written to how secure that code is based on current vulnerabilities and threats to what our risk level is for our hosting infrastructure and how it operates in our production environment. So we've seen a lot of DevOps success at our affiliates and from the pilot projects we've been doing internally at Aetna. By using the same approaches and tool sets for multiple organizations and multiple environments, we ensure consistency for our risk reporting. And by gathering KPIs, we can also quickly identify which part of the organization needs most attention from our security team. With our traditional approaches, we had brought the defect density down to 1.0, but when we implemented DevOps, we noticed that we lowered that defect density to 0.1, and in some of our affiliates cases, we lowered it to 0 by using those gated check-ins and those thresholds. Our plan is to use DevOps across the organization for any new development and to try to realize a similar kind of defect density decrease. Finally, when we isolate feature functionality, develop code into microservices, apply our security policies, and then containerize, we create highly portable and secure applications that we can distribute and deploy everywhere. So we face some challenges moving towards DevOps at Aetna. Changing the mindset of over 3,500 developers can be quite daunting, and having them change their mindset about creating software, it's no simple feat. In some cases, due to budget constraints or the nature of the product itself, it maybe makes no sense to do anything to that process. But as we sunset products and applications across our enterprise, we have the opportunity to take a step back, retool, and in some cases, we're investigating creative ways of incrementally migrating teams to microservice architectures. Although not necessarily an issue, having multiple DevOps flavors in an organization can present challenges. Everybody does a different DevOps or has different ideas of what DevOps is. And at Aetna, we recognize the unique team cultures that exist throughout the organization, as do we the different tool sets that each of these organizations use. And our goal is to try to make security transparent and keep these distinct DevOps cultures intact. Being a global organization, we definitely have challenges in ensuring that our security tools and processes can be accessible from multiple locations. For example, traditionally we would install a static code analysis server in multiple locations, but we never had them connected. So one of our goals is to make sure we centralize this information, gather our KPIs and our metrics, and push those into a centralized location so we can compare and keep track of what people are doing absolutely anywhere. And one final challenge I'd like to point out is more of a question, is how do you integrate manual processes into the life cycle? So penetration testing and these kind of things. Our pull request process, we had that manual code review. For now it'll suffice, but there's a lot of questions about what do you do with manual intervention? Like what happens if you're waiting on an approval or how do you escalate this? So this is where we try to stick to our idea of focusing on the creative and innovative alternatives to manual functions. So finally, a few takeaways that I'd like to leave you with before I end my presentation. First of all, you need to find out where DevOps is happening in your organization, especially in large enterprises. You may find pockets of teams that are practicing DevOps. Reach out to them, learn from them, figure out a way to align your software security program and objectives with them for adding security into the DevOps process. Look for places in your software development lifecycle where you can easily integrate security controls in a similar fashion to how we implemented ours. At Aetna, one of the primary focuses we have in regarding to integrating security into the SDLC is to ensure it doesn't choke the process and introduce unacceptable delays in producing and releasing high-quality software. Think of ways to turn your DevOps culture into DevSecOps culture. After all, it takes an entire organization to support DevSecOps. In conclusion, keep learning, keep securing, continuously improve your processes, and as you repeat this over and over in your organizations, you'll find that the products that you develop are becoming more secure and the organization is reducing its overall security risk. Thank you.